Welcome to week 12 with Mrs. Bibb. This week we'll be reviewing how to solve systems of equations. Please make sure to fill in your table of contents, complete your weekly warm-up and check it. The notes that we have this week are not a student journal page, so all you need to do is to get out a piece of paper. We're going to do 3 examples to review solving systems, and then you'll have an assignment to complete. Okay, so first I'm going to do substitution. I know last year when you solved systems of equations that you spent almost a month in the 8th grade. This was the year 2020. You spent almost a month before we went on quarantine solving systems. You solved using graphing, solved using substitution, and solved using elimination. I know you spent quite some time solving systems. So I want to review how to solve them. If you need more examples, let me know, because I'd be happy to do those examples with you or for you. Just let me know. I'll find more for you that I know I have done. Okay, so I'm going to do substitution first. To do substitution, I always tell students to try to select a variable that does not have a coefficient. Naming my coefficients: 3x minus y equals 2. 3x, 3 is a coefficient. Minus y, -1 is your coefficient. The bottom equation, x minus 2y equals -6. 1x, -2y. So I'm really looking for a coefficient of 1. And only one of those variables satisfied what I was looking for. I'm looking for this variable. I want to get that variable alone because it has a coefficient of 1. So I'm going to add 2y to both sides to get that coefficient alone. Now, when you're solving a system of equations, the system of equations when you're solving, especially by graphing, is the intersection of the lines or whatever type of system you have. And the intersection is at a point, x, y. So that's what we're trying to find. We're trying to find the point of intersection for these lines. And we're going to do this first one by substitution. So I'm going to add 2y. You can write -6 plus 2y or 2y minus 6, whichever one you prefer. The next thing that I'm going to do is I'm going to take this expression, -6 plus 2y, I'm going to substitute it in for x in the top. We're using substitution. I remember when believe it or not, it's been a long, long time ago, I remember when I learned how to do this, and one big mistake that I would make myself is that I would substitute -6 plus 2y back into that yellow x that you see highlighted, and that's wrong. You don't do that. You have to substitute it into the other x, into the other equation. And back when I did this, this was called simultaneous equations. It wasn't called a system. So anyway, I'm going to substitute that -6 plus 2y in. Everything else will remain the same. The 3 remains the same. The minus y remains the same. The equals 2 remains the same. The only thing I'm doing is replacing x with -6 plus 2y. I'm going to distribute -18 plus 6y. Bring down minus y and bring down 2. Combine like terms, -18 plus 5y. Add 18 to the other side to solve. Divide by 5. Y equals 4. So in my solution, here's my solution. Y is 4. How do I go about finding x? What I do is I take this 4 and I substitute it back somewhere. And you can put it in any place for y. But I will tell you honestly, I think it's easiest to take it back to right here. Because my x is already alone, all I have to do is do x equals -6 plus 2 times 4. Instead of y, I'll put 2 times 4. X equals -6 plus 8, so x equals 2. My solution to my first example, solving using substitution, is 2, 4. If I were to graph those two lines, I would see that they intersect at the point 2, 4. Now I want to do elimination. Elimination, this is what, when I sum up elimination, this is what you do. The first thing you do is choose a variable. You make the coefficients the same but opposite of one another. Then you add, and then you substitute. That's how you do elimination. And I'll tell you honestly, elimination is my favorite way to do this because I think it's the easiest way. Oftentimes I'll just solve for x. I'll get rid of get rid of x, eliminate x. So that's what I'm going to do. I'm going to eliminate x. The coefficient of my x in the first equation is 3, and the coefficient of my x in the second equation is 1. I want to find the multiple, and this one's easy, but I want to show you because not all of them are as easy. For some of you, they probably are. But you want to find the multiple that they have in common. What multiple do they have in common? Well, let's go through, and I'm sure you all probably know this. 3, 6, 9, 12. Those are multiples of 3. Multiples of 1. 1, 2, 3, 4, so on and so forth. Those are multiples of 1. What do they have in common? 3 is what they have in common. So that's what I want to make sure both of those coefficients are, is 3. So I'm going to multiply both of those equations by something to either keep them a 3 or turn them into a 3. For the top equation, it's already 3. So I'm going to multiply the top by 1. The bottom equation, that black where I have that underline, isn't a 3, it's a 1. What can I multiply by that 1 to turn it into a 3? Well, I can multiply by 3. All right, so I've got my coefficients the same. Are they opposites? Is one a positive and one a negative? No, they're not. So I'm going to select one of these blue numbers, either 1 or 3, and make it a negative. And I'll just choose the 1. It really doesn't matter. You could have chosen the 3, and we would get the same answer. Now I'm going to distribute the negative 1 and the 3 into these equations. I'm going to distribute, I have to multiply everything by that. So negative 3x plus y equals negative 2. Distribute the 3 on the bottom. 3 times x is positive 3x. 3 times negative 2y, negative 6y. 3 times negative 6, negative 18. Then I'm going to add these two together. Negative 3x plus 3x is eliminated. 1y plus negative 6y is negative 5y. Negative 2 plus negative 18 is negative 20. Divide both sides by negative 5. Y is going to equal 4. Okay, now I do need to substitute. We added, and now we need to substitute. So we're going to substitute this 4 in for y somewhere. It doesn't matter which y you choose. I think I'm going to go up and put it in for this y right here. 3x minus 4 equals 2. I'm going to add 4 to both sides. 3x equals 6. Divide by 3. X equals 2. So 2, 4 is my solution to the second one. Now, this third example is where students just lose it. They're like, I cannot do word problems. I can't do it. I can't do it. In fact, I got a message from someone the other day that said they just can't do word problems. Yes, you can. Yes, you can. Yes, you can. I know you can. Okay. Here's the first thing that you do when you're doing word problems, especially in algebra and these kinds of word problems. Define your variables. That's the first thing that you want to do. And you may want to write down, you might not have to write all of them, but you may want to write down part of what that word problem says so that you'll have this in your notes to help you in the future. Okay, look for what it's asking you to find. What is this word problem asking you to find? Find the price of an adult ticket and the price of a child ticket. That's what you don't know. You don't know the price of adult tickets and the price of a child ticket. You don't know. So X is going to stand for the price of an adult ticket. Y is going to stand for the price of a child ticket. So you could go back right now into this equation and you can say this is X. This is Y. This is Y. Then what else do I have? I see adult tickets, that's X. And I see child tickets, that's Y. All right, we're going to put everything that goes together. The school that Juan goes to is selling tickets to the annual talent show. So that first sentence doesn't really help me to write my equations. It's just there for information. The second sentence, on the first day of ticket sales. So all of this information is the first day of ticket sales. The school sold 12 adult tickets, or 12X, and 6 child tickets for a total of $216. That is my first equation. A total is add. The total is $216. What did they sell to get that total? They sold 12 adult tickets, 12X, and 6 children's tickets to get that total of $216. Let's look at the next sentence. The school took in $91 on the second day by selling 3 adult tickets and 10 child tickets. Okay, that will help us with our next equation. A total of $91. So a total of 91. Total means you're adding things together. What are you adding together? The money taken in for 3 adult tickets, so 3X, and the money taken in for 10 child tickets, so 10Y. I have my system of equations just by reading the problem and putting the things together. One thing I want to re-emphasize, anything that I highlighted in green, I would not reuse again. So the 12, the 6, and the 216 that I put in that first equation, I would not reuse those numbers. The 3, the 10, and the 91 that I put in the second equation, I would not reuse those numbers. Now you know that I like elimination, so I'm going to use elimination. I am going to eliminate X. I am going to write the multiples of those numbers up here at the very top. 12 multiples of 12. 20, well, I should include 12 also, shouldn't I? That would include 12, 24, 36, 48, multiples of 12. Multiples of 3. 3, 6, 9, 12, and there it is. 12 is the number they have in common. So I want both of these numbers to be 12, and I want one of them to be a positive 12 and one of them to be a negative 12. What will I multiply this by to keep it a positive 12? 1. What will I multiply this by to turn it into a positive 12? 4. Are they opposites? No, so I have to make one of them a negative. If they were opposites already, I do not need to make one of those blue numbers a negative. Now let's multiply. Negative 12X, negative 6Y, negative 216, positive 12X, positive 40Y equals 364, I think. 4 times 1 is 4, 4 times 1 is 36, yes. Add them together. Negative 6Y plus 40Y is 34Y. 364 minus 216, and I am going to use a calculator on that one just because I don't want to trust my brain at the moment, is 148. I'm going to divide that by 34. And and I get $4.35. Y is going to equal $4.35. I had to round on that one, so I don't know if I just mistyped that problem. I didn't see any mistakes as I went back through it. If you see a mistake, please let me know. I had got 4.3529, and that can't be right. Well, it has to be right for this problem. It seems like it is. I went through all my work to see if I did anything wrong. Okay, now I need to find the x. What am I going to do to find the x? I am going to substitute 435 in for y in one of my places for y. So let me find that. I think I'll just use the bottom one. Multiplying by 10 is much easier to me, I think. So I'm going to substitute 435 in for this y. Where I'm going to squeeze all that work, I don't know. So I'm going to have 3x plus 10 times $4.35 equals 91. I'm going to multiply 10 and $4.35, and I believe that would be $43.50 equals 91. I'm going to subtract $43.50 from both sides. I apologize for that being so tiny. Let's see if I can find me a space around here. I'm going to take this to the very top. 91 minus 43.50 is 47.50. 3x equals 47.50. Divide both sides by 3, and you get $15.83. Most of the time, your answer is going to come out evenly. I had to round for that, so I must have typed something incorrectly there. Now, I don't want to leave this problem that way. I want to write my answer in sentence form. So up here at the top, I'm going to highlight. In this space, after I stop talking, I'm going to write in the interpretation that you should have of this problem. And our answer tells us that the talent show tickets cost let's see, $15.83 for adults, and look, I'm all out of space, and $4.35 for students. And I tried to erase that and that didn't work. And $4.35 for students. I'll read that to you again just in case you cannot read that scribble underneath there. Whoa. So this says the talent show tickets cost $15.83 for adults and $4.35 for students. That is the real answer to this word problem here. So hopefully that helps you remember how to solve a system of equations using substitution and elimination. You have practice problems to do. There's nothing from the textbook this week, but you do have practice problems that you need to complete. I will tell you, please omit number 5. Please omit this one. It is very difficult. If you'd like to try it for fun, you're welcome to, but please omit number 5. That's way more complicated than what we need. And then try your best. If you need any help, let me know. I'll be happy to help you. I think that's it. Have a wonderful day, and reach out if you need me for anything.